Today I'm going to show you what you need to know about sketching tangent and cotangent functions without a graphing calculator. First of all, the tangent of an angle is equal to the sine over the cosine. Hopefully you remember that from last year. So if I wanted to graph this, this is a rational function, and it has a VA every time cosine of x is equal to 0. And the x values where the cosine is equal to 0 between 0 and pi over 2 is x is equal to pi over 2 and 3 pi over 2. If you can imagine the cosine curve going through the x-axis at those 2 points. So it's got the vertical axis, or vertical asymptote is there. And it's also at negative pi over 2 and negative 3 pi over 2. So I'm going to put a plus and minus in front of those. Now it has x-intercepts, or this is equal to 0 anytime the sine is equal to 0. So the x-intercepts are when sine of x is equal to 0, and sine of x is equal to 0 at x equals 0 and pi and 2 pi, and you can put a plus and minus in front of the pi and the 2 pi. So those are important points. And the other thing that the tangent has is tangent is equal to 1, and you probably remember tangent is equal to 1 at pi over 4. But it's equal to 1 whenever sine is equal to cosine, because anything over itself is 1. So it's equal to 1 when sine of x is equal to the cosine of x. And that happens at x equals pi over 4, because that would be the square root of 2 over 2 for both of those values, and 5 pi over 4, which is negative square root of 2 over 2. So that's where it's equal to negative 1, or positive 1, and the tangent is equal to negative 1 when sine of x is equal to the negative cosine of x. So where does that happen? That happens in quadrant 2 and quadrant 4. So that's x is equal to 3 pi over 4 and 7 pi over 4, if you're talking about the interval between 0 and 2 pi. So I'm going to just set up my x-axis. I can set up my y-axis because I'm not going to ask you to shift or stretch a tangent graph. You just kind of have to know the basic tangent graph, which you might remember from last year anyways. So the important points, I think we'll go out to 2 pi on the positive side and negative 2 pi on the negative side. And we'll have pi in the middle, and pi over 2, and 3 pi over 2, and the negatives. So our vertical asymptote that we stated up here was x equals plus and minus pi over 2. So we'll dot that for our asymptote. Plus and minus pi over 2. And plus and minus 3 pi over 2. So we'll actually see 3 full cycles of this tangent graph, and if we go all the way out to 2 pi, we'll have a half a cycle over here. The period of the tangent graph that doesn't have a frequency in there, the period is pi, not 2 pi. And there's no amplitude on a tangent graph because the tangent graph goes up forever and down forever. So there's really no height. So there's no amplitude. So the x-intercepts are where x equals 0, x equals pi, and 2 pi, and the negatives. And then the other important point is y equals 1 at x equals pi over 4, which is the halfway point here. So here's the 1, and here's 5 pi over 2, y equals 1 there. And then at negative pi over 4, it goes down to negative 1. And at 3 pi over 4, it goes down to negative 1. At negative 3 pi over 4, it's positive 1. At negative 5 pi over 4, it's negative 1. And at negative 7 pi over 4, it goes back up to positive 1. So we have 3 major points in each cycle of these 3 cycles. And how this is sketched is you're going to have a concave up part between 0 and 1, and then it continues to be concave up and follows the vertical asymptote to the right, and then to the left of the y-axis it's going to be a concave down graph. So we're coming down, and there's one cycle. The one cycle has a length of pi. So we'll draw our second cycle here between pi over 2 and 3 pi over 2. Here's 2 cycles. We'll draw our third cycle over here between negative 3 pi over 2 and negative pi over 2, making sure the concavity is correct. And then over here, if you wanted to finish it up at 2 pi, then we have a negative 1 value here at 7 pi over 2, and this is concave down. And then over here at negative 7 pi over 2, this part of it is the concave up part. So this tangent graph is always increasing. As you move from left to right, the tangent graph continually goes up, even though there are arrows that go down. If you're moving from left to right, this is an always increasing graph. So that's all you have to know about the tangent graph. If I do have a coefficient in front of the tangent graph, like if I had a 2 tangent of x, the only difference you'd have to make here is you'd put a 2 here on the y-axis and a negative 2 down here. But still the basic shape is still the same. It just gets vertically stretched by a factor of 2, which just means these important y values change from 1 to whatever this value is here. So I guess if we wanted to change this to a tangent of x, a sine of x over a cosine of x. Oh no, over cosine of x, because a's would cancel out. Then instead of having a 1 here, we could put the letter a, whatever this a value is, 1, 2, 3, 4, whatever it is. Right, so that's the tangent graph. And then the cotangent graph is similar, because cotangent is just cosine over sine. So the cotangent of x is equal to the cosine of x over the sine of x. And again, we have a vertical asymptote whenever sine is equal to 0. And sine is equal to 0 at x equals 0, plus and minus pi, and plus and minus 2 pi. It has x-intercepts when the cosine is 0. And the cosine of x is equal to 0 at plus and minus pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. You could keep going. All right. The cotangent of x is equal to positive 1 and negative 1 in the same places where tangent of x was positive 1. So it's equal to 1 when sine equals cosine. And we've already listed those values above, so I'm not going to list them again. And it's equal to negative 1 when they're the opposites. Sine of x is equal to the negative cosine of x. That's 3 pi over 4, 7 pi over 4. So if you graph the cosine of x curve right on top of the tangent of x curve, you're going to get those points to coincide with each other, the ones and the negative ones, because they're equal to each other at those points. But we'll draw a totally different cotangent curve to see what that looks like. Again, the period is equal to pi, and there's no amplitude. even though there could be a coefficient out in front of the cotangent. So we'll go out to 2 pi, go back to negative 2 pi. Now this time the vertical asymptotes are x equals 0, pi, and 2 pi. So we're going to dot the y-axis as our first VA. Our second VA is going to be x equals pi and x equals 2 pi. It has x-intercepts when cosine is equal to 0, so the x-intercepts are at plus and minus pi over 2 and 3 pi over 2. So we'll mark those x-intercepts. And then the last thing we're going to do is place the values where the cotangent is equal to positive and negative 1. So at pi over 4, it's equal to positive 1. At 3 pi over 4, it's equal to negative 1. So what we have here is we have one cycle going between 0 and pi, but this time this graph looks like this. It's concave up to the left, and then it goes concave down. Put arrows at the end. Over here, it's equal to positive 1 here at 5 pi over 4, negative 1 at 7 pi over 4. And then we're going to actually have 4 complete cycles. And here's negative pi over 4 and negative 3 pi over 4, negative 5 pi over 4, we'll go down to negative 1, and negative 7 pi over 4 will be positive 1. So there's the cotangent graph, and right here this value is 1, and this value is negative 1. Unless there's a coefficient in front of the cotangent, then we could put whatever that coefficient is. So instead of this graph being increasing, this graph is always decreasing. So there's your cotangent function with all the VAs. And you could label them all too with their equations: x equals 2 pi, x equals pi, and x equals 0, and x equals negative pi. And we probably should do the same thing up here. X equals 3 pi over 2, pi over 2, negative pi over 2, negative 3 pi over 2. So we've got everything labeled. Next thing I'm going to show you is the reciprocal of the cosine function, which is y equals secant of x. The reciprocal of the cosine, which would be y is equal to 1 over the cosine of x. And again, just like the tangent graph, this has vertical asymptotes where cosine of x is equal to 0, and that is at x equals pi over 2, 3 pi over 2, etc., just like the other one. So I'm going to show you what you need to know about a secant graph being the reciprocal of the cosine graph. One way to start out drawing a secant graph is to just lightly draw a cosine graph first. So we'll go out to 2 pi. And I think I'll graph lightly the cosine of x graph in red. we can get an idea of what the reciprocal graph would look like. So here's y equals cosine of x. Now this has a vertical asymptote wherever cosine of x is equal to 0. That's all the x-intercepts. So we can right now sketch in our vertical asymptote. All of them. There are 4 in this interval. All those x-intercepts. X equals negative 3 pi over 2, pi over 2. Now the cosine equals 1 when x equals 0. The reciprocal of 1 is 1. So 1 over 1 would be the secant graph. The secant graph touches the cosine graph right here at this peak. And if you take the reciprocal of all these numbers between x equals 0 and x equals pi over 2, you're actually going to get a parabola-shaped graph. And it's going to come up like this and this. And there's the first part of your secant graph. That's a half of a cycle. Over here, the reciprocal of -1 is -1. So your secant graph is going to touch your cosine graph right here at x equals pi. And it's going to come down this way. And it's going to go against those vertical asymptotes. So this right here, between negative pi over 2 and positive 3 pi over 2 is one full cycle of a secant curve. One full cycle has a opening up graph and an opening down part of the graph. So there's one full cycle. If you wanted to put an additional half of a cycle in, you could here. It touches all of the local minimums are the places where the secant and cosine touch each other. So there's a half of a cycle over here. And you could actually make a quarter of a cycle here if you wanted to come up here, and then another quarter of a cycle up here. So you've got one full cycle here, and then you've got another full cycle between all these little portions here. So there's your secant. And then the only difference with a secant is if you put a coefficient in front of the secant, like a 2 or a 3, instead of this y value being 1, and this y value down here being -1, it would be whatever that coefficient is. So it could be it could be stretched up, or it could be shrunk. So there's your secant curve. It touches the cosine curve at all of those local mins and maxes. And then for completeness, we'll do y equals cosecant of x. Cosecant of x is the reciprocal of the sine of x, and it has VAs where the sine of x equals 0, and that is x is equal to 0 plus and minus pi plus and minus 2 pi, just like on the other ones. And so if we graphed a cosecant graph, cosecant graphs look like secant graphs, but they're just shifted over, just like sine and cosine graphs are shifted over from each other. So we'll go out to 2 pi and back to -2 pi. All right, what I'm going to do is going to lightly sketch in a sine curve in red. And wherever you have the local maxes and mins of the sine curve is where the cosecant curve is going to touch. The cosecant and sine touch at those points. They're tangent to each other. So there's the red is y equals sine of x. And your vertical asymptotes are all of the x-intercepts. So here's one at x equals 0. Here's one x equals pi. Here's an x-intercept at x equals 2 pi. And then again, the reciprocal of 1 is 1, so the cosecant curve is going to touch the sine curve here, and it's going to be a parabolic shaped graph, opening up and opening down. So there is one full cycle, an up and a down, opening up and an opening down is one full cycle. Now we'll get another half of a cycle over here, and we'll get another half of a cycle over here. So again, if you were ever asked to graph a secant or cosecant, my suggestion would be to first graph the reciprocal, graph the sine or cosine, and then just connect them at those locals. And then you've got it. And that's it for today.